How you doing? We're going to do a little test on some batteries. First, we're going to identify the battery style and type. We're going to look on the front of the label. The first number we see down in here is the BCI, the Battery Identification Code number. That number puts the battery into the group. So the casing, the style of the plates, and the size and width dimensions of the battery. Next identification marker on here is your cold cranking amps at 32 degrees Fahrenheit, which is 1140 cold cranking amps. Third one is the cold cranking amps at 0 degrees, which is 950. Also on here, you're going to have your serial numbers for the style of the battery from the manufacturer. Up on the upper portion at various different spots of the battery, you're going to end up having the date the vehicle was, or the battery was put into service. So that way, for warranty reasons, so that should always be peeled off with the month and the year. First, I'm going to do a little test on the status of the batteries. So I'm going to set my trusty handy dandy multimeter here to voltage. Turn on the light to make it a little simpler to see. And we're going to test this stack of batteries. There are currently 4 batteries located right here. They are all 12-volt batteries, and they are hooked up in series. So they are all within the 12-volt series, or as you were. They are hooked up in parallel, not in series. The set of batteries are within 12 volts. So the negative on the negative, the positive on the positive. Let's try it that way. And I'm getting 12.86 volts direct current. So now I'm going to remove a battery, and we're going to do a load test on that individual battery once removed. Disconnect the battery and remove it from the vehicle. So that way we're going to do the bench test. First thing you're going to do is obviously, these are screw posts, it's a ratchet, the appropriate size socket, remove the nuts. One of the things you want to be careful of is these terminals. You don't want to cross paths on the terminals with your tool, otherwise you're going to short circuit yourself and the battery, possibly creating a danger to a shock danger, electrocuting yourself, or burning something. Also, you're going to want to protect the actual cables themselves, connecting any of the metal parts of the vehicle. So that way we don't short out any of the other fuses, circuit breakers, or the remainder of the batteries. So I'm going to disconnect it now so we can remove it. Put the hardware back on so that way we don't lose the hardware. Now that I'm touching the positive side, I'm going to cautiously not touch the vehicle, otherwise I will be grounding out the battery. Now this battery is disconnected, and I'm going to continue on the others. So we'll come back on the bench though. Alright, now we're going to do a load test on this here battery right here. So we got a solar 1000 amp carbon pile load tester. What this does is first, once we hook it up, before that we want to choose what variants of battery we have. We go from 6, 12, and 24 volt systems. You're going to have a DC voltage reading right here, and your DC amperes right here. So, being that this is a 950 amp cold cranking amp battery, we want to cut that in half to 475. So go ahead, hook up the positive, hook up the negative. Once the needle calms down from bouncing, we'll see that it's at about 12.3 amp. That's 12.3 volts direct current. So now we're going to twist this knob, applying a load counterclockwise or clockwise, applying a load till this gets up to about 475. Then we're going to come back and find out, ensuring that this is in the green, stating that this is a good battery. So I'll start applying the load to it. Coming up, as we see, we're about at the 475. We'll let it sit for a second. We'll notice that it's still within the green, hasn't dropped below 10 volts. But I do not, or 9 volts, and I don't want to keep it on too long. The battery starts smoking, so I'm going to apply it. And that warning sign right there is meaning that we're drawing a lot of amps and a lot of current off the battery, and we're going to start destroying the battery. So that's a simple load test on a battery. Now, very carefully, disconnect the negative, disconnect the positive, give it a second. A lot of the current was passing through these, so So they're a little on the warm side, same with the battery. So you're going to want to wait a second before you go and reinstall the vehicle. And that was a little test on the vehicle, on the back cover. Cleaning of the battery terminals, battery cables, inspecting and cleaning of the battery box. So first, using your battery brush, you have your terminal lead brush right here, the raised post terminals. You can also use it very minorly on the screw terminals. And also you got your terminal cable brush, cleaning and maintaining the inside of the terminals there. So for the battery, every so often, 3 months to 6 months, you want to inspect your battery compartment for corrosion. You want to build up with dirt, loose connections, and then give it a good little cleaning to making sure you're getting the proper amount of voltage and amperes through the system. So, with your terminal post, if you got that type of post, get it on, give it a turn or two, take it off, nice clean surface. Go to the other post, get some turn or two, nice clean surface. The ones with the nut, take the hardware off. Hit that up again with this, using it on the threads. Probably get away with using just a small one, depending on the amount of small corrosion. Or you can bring out the bigger, for deeper cleaning with a larger wire brush. Again, safety on the terminals though. You don't want to cross paths. On the end of the harnesses, you want to look for the corrosion. That green stuff right there has got a little bit amount of corrosion. So we're going to want to hit that with a nice wire brush. You can use some chemicals, just making sure they're safe for battery terminals, battery connections. So we'll go hit that a few times with the wire brush, top and bottom. Start with the top. Turn it over to get this one up there. Just use it like such. Get some cleaner. Just keep going and rub until you're going. But anyway, we're going to move on to the video. For the battery box, being that this is not a sealed compartment, you're going to have enough nice amount of dirt build up. Have a few extra parts that sometimes fall in. Again, you want to inspect it on a regular basis. You can use your brush, use a rag, wipe it down, brush it out, clean it all off. Check for any other corrosions, build up with battery acid. If you see any battery acid from a leaky battery, baking soda. You want to put that out, it'll help neutralize the battery acid and then dispose of the hazardous material properly. But continue, make sure all your connections are good and clean prior to reassembly. Checking all the hardware, making sure the battery box is tight, not falling off, and all your cables, looking for any frayed, loose connections, any broken connectors. This one here looks good. We're going to clean it up, throw it back together. Alright, we're going to test the state of the battery charge on here, find out which one of these two are a good or a bad battery, and then if we got a bad battery, hook it up to a charger, see if we can recover some life out of it. So we're going to take our multimeter, set the volts with direct current, let it all zero out a little, positive and negative. This battery here shows 12.33 volts. So the voltage is good. We aren't sure of the amps, so we have to use an amp tester or a load tester to find that out. Let's try this Optima red tab. Top, positive and negative. Alright, this one here is down to 5.75 volts, or 72 volts. So this one here, we're going to hook it up and see if we can get a better charge on it. This is the battery charger. This one here, again, in DC and amps. So, it has various different abilities, charging up to 200 volts, 200 amps, 12 volts, to possibly remotely start a vehicle if you have a dead battery, just like you jump start your car. But it also has various settings from 6 up to 24 volts and various different amp ranges for a quicker, more speedy charges. It also has a time here, so you can put a time limit on it. This is also your go switch. Make sure it's plugged into the wall. Alright, then we'll take the positive, hook it up to the plus sign for the positive, negative off to the negative. Twist them a little bit, make sure they got a good charge. Now, for 30 amp, we can set it on here, get a charge for it, but it's going to take a while. 60, again, it's going to expedite the process of charging it up on 60 amps. However, for 30, I could set my timer for about 20 minutes, 30 minutes, walk away, go do another job. If I'm going to do 60 or anything higher, I'm going to want to maintain close proximity to this battery and the charger, making sure that we're not overheating the battery or the charger. So I'm just going to put it here on 30 amps, click my timer to engage the electrical flow from the charger out of the wall into the battery. So we'll put this on for in there between 30 and 40 minutes, and I have zero voltage coming out of it. So let's see if it'll switch over to 60. Brings it up a little bit. That right there means that this battery is too low to charge. So this test right here also tells me that battery is about as defunct as it's going to get, and there is no life for it, so we're going to just have to dispose of it. So we'll turn it back, take this back to the off, and we'll go try another battery. Now we're going to go and try it on the other one, see what the amperage and the voltage or the amp rating on this charge actually comes down to. Negative, negative, positive, positive. We're going to leave it on the 30, take it over here to 15. That is a very low charge to it. So let's go with that. The charge on it right now is about 10 amps. And over time, the charge rate will drop it down slowly. So we're going to bump this up to 60, speed it up, brings it up to closer to 40 amps, which is getting a little bit more power and juice into it. So we're going to leave it here to sit and see how it goes. We are going to pay close proximity to it to the amount of power coming out of this box and into the battery. We'll see back here in a couple minutes. We're going to show you an example now on how to jump start a vehicle. This is where a dead vehicle didn't want to start. We're going to represent this battery as a live vehicle, fully operational. Our method of destruction today are going to be some jumper cables. First, we're going to go to the negative vehicle where it doesn't operate. Getting our jumper cables correct. So we got one set negative or negative and positive, the other set negative and positive. First, keeping these guys separative, we're going to hook up our disabled vehicle. So I'm going to ground negative on the engine block. Then I'm going to go and use the positive cable on the positive terminal of the battery. Then I'm going to go to our good vehicle, hook up positive to positive first, negative to negative then after that. And then I'm going to have my assistant attempt to start the vehicle. Vehicle starts, disconnected in the exact same order, in the reverse order. Take off the vehicle ground, black cable first, then the positive, keep them separated, come positive, and then take off the negative. There are various different ways in which order you want to hook up. Positive, positive there, positive over here, negative here, or vice versa. The importance on it for safety, do not touch, keep the connectors together. Whether it's positive to positive, the negative to negative, or negative to positive when you're hooking it up. That's how you jump start a car.